Let's have a look at what we call the additive inverse. Now, additive inverses are numbers that are numerically the same but different in signs. If I have 5, then I'll have positive 5 here, negative 5 and positive 5. These are additive inverses. If I have x over 7, I'll have negative x over 7. There's the additive inverse. Additive inverse. Not that this is equal to that, but that the additive inverse of this number is this number. Now, I hope you appreciate that the sign here is positive and the sign here is negative. And these numbers are numerically the same, but they just differ in terms of signs. So these are called the additive inverses. Now, so let's have a look at the use of the additive inverse in helping us to solve an equation. If I have x plus 2 is equal to 6, now I hope you realize that our interest lies on the unknown, the variable. And the unknown here is x. So this is plus 2. Now the additive inverse of positive 2 is negative 2. Now that is equal to 6. Now on the left of an equation, we have introduced a negative 2 here. We must do the same on the right-hand side. What you do on the left-hand side of an equation, you do on the right-hand side. So 2 minus 2 is a 0. So a number added to its additive inverse, or a number and its additive inverse add up to 0. The sum of a number to its additive inverse is 0. And then you'll have 6 minus a 2, which is a 4. Therefore, your x is equal to a 4. Quick check, 4 plus 2 is 6, which is correct. Now let's look at the second one here, where you have y minus 3 is equal to 5. Now, our unknown here is y. We are supposed to solve for y, not y minus 3. So we need to get rid of this foreigner here, rid of this foreign element here. We remain with the y minus 3. For us to get a 0, we set a number and its additive inverse gives us 0. So we are going to add a 3 here. That is equal to a 5 there. Now on the left-hand side, what is foreign is this. That's what we have added. So on the right-hand side, we must do what you did on the left of an equation. On the left, we have added my plus 3. We must add plus 3 there. Now, this is a number and its additive inverse. Numbers which are numerically the same is 3, but different in signs. I repeat that for emphasis. Is that y will equal to 8 So 8 minus 3 is 5. That's very true. That's your answer there. Yeah, y is equal to 8. That's what we do there. Now, let's have a look at another thing called reciprocal, or what you call the multiplicative inverse. Reciprocal. Reciprocal, or what you call the multiplicative inverse. Now, let's look at this number here, 3 over 5. Now, that's the number there. The reciprocal of this number is going to be 5 over 3. Now we have taken the numerator and the denominator. Here, the denominator becomes the numerator becomes the denominator. This is a reciprocal of that. Let's take the next one. Minus x over 9 will equal to negative 9 over x. Now be careful. Here, we just invert the denominator to be a numerator and a numerator to be a denominator. The sign is negative there, the sign is, this has nothing to do with the sign, positive or negative. It only has to do with the fraction. We change the fraction that way. We say the additive, the multiplicative inverse of negative x over 9 is 9 over x. Not that this is equal to that. I mean the multiplicative inverse, the reciprocal. The reciprocal of negative x over 9 is negative 9 over x. Now let's see, where does this come in handy? We are going to have a look at equation 1. Let's call it A, where we have 3 over 8x is equal to 24 or let's say it's not 24, let's say it's equal to a 2. Let's make life easy. Take a small number there. This is equal to a 2. Now, this is 3 over x, 3 over 8x is equal to a 2. The multiplicative inverse of 3 over 8 is 8 over 3, 8 over 3. Now is 8 multiplied by 8 in fractions gives us 24. 3 times 8 is 24. 24x is equal to 2 times 8 is 16 over 3, because there's a 1 there. A number over itself is a 1. So x will equal to 16 over 3. That is your x. Now let's take B and C. Take B here and write negative 2/3 B is equal to 6. Now, this is negative 2/3B is equal to 6. We look, because we multiply negative 2/3 by B, we need to get the multiplicative inverse of negative 2/3, which is negative 3/2. Now on the left-hand side, we have multiplied by 3/2, which is 1.5, of course. On the right-hand side, we do the same. Now, a number multiplied to its multiplicative inverse, we have seen here that the answer is 1. So you have 1B there. We have a B there, which is equal to 3, the same as what? Number over 1 here. 3 times negative 6, or 6 times negative 3 is negative 18/2. 2 into 18 goes 9 times. And that is what you got there. B is equal to negative 9. Now, you have seen how we use the reciprocal. If you go back to the previous page, you have seen how we use the additive inverse. In the next one, we are going to combine the additive inverse and the multiplicative inverse. We are going to combine the additive inverse and the multiplicative inverse. Let's give it a go. We say here, 3/5 x minus 2 is equal to 13 here. Let's write L. So we are challenged to look for the unknown here, which is x. But now it's 3/5 x minus 2. We need to first get rid of this negative 2. We will write 3/5x minus 2. The additive inverse of negative 2 is positive 2. And we write 13 plus a 2, which gives us a 15, of course. So 3/5x is equal to a 15. Now, these are 3/5 x. We are looking for x. We need to get rid of 3/5, which is called the coefficient of x. We are going to multiply by the reciprocal of 3/5, and the reciprocal of 3/5 will be 5/3. Then what we do on the left of an equation, we also do on the right. And then this will give us a number multiplied by its reciprocal. The answer is 1, so we have 1x there. And then you can say 5 times 15, or 15 times 5 is 75, divided by 3, because we have a 1 there. You know, any whole number is over 1. 1 times 3 is 3, 15 times 5 is 75. We also know that 3 into 75 goes 25 times. Therefore, your x is equal to 25. Now, we have used the additive inverse there. We have made use of the multiplicative inverse here. So we are going to do another example. Which looks like -2 over 3 y minus 4 is equal to 2. Our unknown here, our unknown is negative, is y, and then the coefficient of y is -2 over 3. We say we need to get rid of this first. We will write -2 over 3y minus 4. The additive inverse of -4 is +4, and that is equal to 2, because on the left we have added +4. On the right, we should do the same to maintain the equality. So here we realize that we have a number and its additive inverse. And we said the sum of a number to its additive inverse is 0. 4 minus 4 is 0. We will remain with, on the left here, 2 over 3y is equal to 6. Now, we have not yet solved for y, because this is 2/3 y. This is 6. We need to multiply by the reciprocal, or the multiplicative inverse of -2, which is -3 over 2, multiply by -3 over 2. Now, a number multiplied to its reciprocal, so the answer is 1 there. So 1 is equal to 6 times -3, which is -18. 1 times 2, which is a 2. 2 into 18 is a 9. Therefore, y is equal to a 9. Y is equal to a 9. Now, we are going to do the last one. The last one look like look like 4 over 5 x minus 3 is equal to 17. Now we need to get rid of this first. So 4 over 5 x minus 3. To get rid of that minus 3, we add a 3 on the left, and then that will equal to 17, but on the left of an equation, we have added a 3. What you do on the left, you do on the right. So that will be 4 over 5x. A number and its additive inverse is 0. 3 minus 3, nothing remains, but 17 plus 3 is 20. Now you have 4 fifth x is equal to 20. Now we need to multiply by the reciprocal of 4 over 5, which is 5 over 4. 5 over 4. A number multiplied by its reciprocal, the answer is 1. Because 5 times 4 is 20. 4 times 5 is 20 over 20. That gives you 1. But 20 times 5 gives you 100. There's a 1 there. You know that the whole number is over 1. 1 times 4 is a 4. And then we will have x is equal to 4 into 100 goes 25 times. That makes up the number. Hope you realize what's going on here. And that's the end of our view of additive and a multiplicative inverse. The product of a number to its multiplicative inverse is 1, but the sum of a number to its additive inverse is a 0. Bye.